Before going into more detail on ohming out and checking out this and all that crap in the choke department, I know that looks like a mess. You know, I'll tell you, that is a mess. I'm going to have a really tough time figuring all this out, but if I sit down with a piece of paper and compare it to the schematic, wire by wire, you know, I'll probably have to do each wire 50 times so just to make sure I know exactly what I'm doing. I might be able to figure it all out. But when I stuck my probe, my two probes on my multimeter, down into the 80 rectifier large holes in the socket, that would be the filament. I couldn't get any reading. No matter what I did, I couldn't get a reading. So I kind of thought maybe the rectifier filament winding in the power transformer might have been open. So I have removed it, and I'm going to turn it over here, and let's go ahead and hook up the red wire. Now this red and black, these two red and black wires, they're the ones that run to the filament from the power transformer. So let's go ahead and connect one here, and let's connect the black one to the other side, which would be right here. This is kind of tough doing it one-handed. And as you can see, we have continuity. Let's take it down a little bit lower scale. There it is, 0.7 ohms. Not bad. Hook it back up. Everything's good to go. So now we know our winding is good. Tell you what, let's go ahead and check this secondary winding that hooks to one side of the secondary hooks to plate 1, and the other side of the secondary hooks to plate 2 of the rectifier. And it is center tapped, you'll notice. A lot of times you'll see the center tap come out of the inside and then go to ground. This one here goes the other way. Goes up here like this and over to ground. Same. So what we're going to do, we'll have to hook our multimeter to ground first, which will be right here. Now this is that connection right there. This is your ground here. We'll go ahead and hook that right there. Now we'll go ahead and first we'll hook the red connection here and the red connection down here on the other thick wire. So let's do that first and see what happens. Here we go. Alright, one half of that secondary is good. Let's check the other half. And there it is, the other half is good. So what I just did was I measured from here up to there, and then from here up to there. And of course this being connected to ground. So this is good. I've already ohmed out all of these. The primary is good, and the filament for the winding for the 80 rectifier filaments is also good. We got a good transformer, folks, as long as there's no internal shorts I don't know about. In order to try to connect a multimeter probe to that thing and start probing around trying to figure out where it goes, I'm going to have to strip some of the wire insulation off. So not much, just enough to give me an end to work with. In order to keep going here, I've got to separate these caps on the opposite end of the ground. I can't make measurements with those two things incorrectly hooked. Alright, these things are not supposed to be in parallel. You can see from the schematic, they're not supposed to be in parallel. These two ends go to ground, but this end goes between the chokes, and this end goes on the other side of the choke. They are not to be hooked together. I don't know why that was done. I'm still working on it. From looking at the schematic, I've determined that one of these capacitors can come out of here. So I'm going to go ahead and whack that baby out of there. Alright, the deed is done. Now here's why. I have continuity from this side of the capacitor, this side to ground of course, and then this side over to the black wire. This thing here isn't even needed, and there is a note up here that says a 1 microfarad condenser is also contained in the transformer condenser housing, but this condenser is not connected in the Model 37 power pack, which is what we have here, the Model 37. So this one is not needed. We can X that baby out, leaving me with just this one capacitor. It's making life a whole lot easier now. As far as I can tell, all I need to do is put a 1.5 in here. However, that'll solve all of this, and all of this will be wired properly. The problem is, I'm still stuck with this stub of wire here. What is that stub of wire? It's killing me trying to figure out what it is. So let's hook up the meter to that stub and see if I get a reading to ground. The multimeter is hooked to the stub, and here's the ground. Keep your eye on the meter over there when I hook this up to ground. And I am getting a reading. It's reading 1,000 ohms, about 1150. Alright, I believe I have figured out what's going on here. The reason we had two capacitors in parallel was that the person who rebuilt this last time apparently did not have a 1.5 microfarad capacitor. So he took two 1.01s and put them in parallel to form this capacitor to ground. This capacitor right here, 1.0 microfarad, according to this note right here, was eliminated in the Model 37. So what they did here was cut this thing right here, and it left the stub from the point where they cut it down into the tar to the capacitor, and then the other side of the capacitor came out and went to ground. And when I measured to ground, I got resistance between here through the cap to here. And that would be normal because capacitors that have been buried down in tar all these years and have deteriorated, gone to pieces, are going to show resistance. So in effect, that capacitor right there is no longer there. We can just go ahead and get rid of that thing altogether on the schematic, leaving just this one right here. So all I have to do is come up with a 1.5 microfarad capacitor and put it in place of those two in parallel. And the rest of this should be good to go because we've checked out every single coil, every winding in the power transformer. We are good to go. Shouldn't be too much longer, except I don't think I have a 1.5 microfarad 200 volt capacitor. There's always something.